Okay, so that last one is so long. This one will be kind of quicker. Section 1.9, an introductory video to that. And what we're really interested in, it's pretty cool stuff, is we're in the world of R2 just to goof around and watch what can happen. If you read the text or you see some of the homework, they use the words such as reflect, scale, rotate, and skew, and all this kind of good stuff, vectors. And you can do it to spaces too. And it's just the beginning of a study of algebra that's, really interesting. But what we want to do is basically learn how to, anyone can take a vector, oh, reflect it across the x-axis. Okay, there he is. He goes down there. And then, oh, you know what I want you to do is I want you to, multiply it by 5 or something. Stuff like that we know how to do. But linear algebra says what we'll do is we'll find if this is vector x, if we just go a times x, it'll do all that for us. Multiplying by a matrix will take care of rotations, it'll take care of stretches, skews, reflections, all that stuff. So I have an example here, and I have a short little talk about why it works, very short. So let's read it. Find a matrix A such that the linear transformation T of x equals A times x reflects any x vector in R2 across the vertical axis, and then scales the resulting vector by a factor of 3. Okay, let's see what they're talking about. Maybe I'll draw another picture here for this guy. So it's fun to go, okay, if I'm in R2, that's easy to see. Okay, and let's say I take a vector wherever it might be, say it's this guy. Call him x, all right? Now remember, that's a graphical picture of a 2-by-1 vector, an ordered pair, okay? And what happens to that guy is what we wanted to do is, I'm going to do this in this color, I'll just go, we're going to reflect him across the vertical axis, there he is, and then we're going to scale it by 3, so he's going to pop out this much longer, and this will be the result if I multiply by this mystery a of x, a times x, I should say. Okay? All right, so we're going to learn, you're going to use the fact that this, any multiplication by a vector or by a matrix is a linear transformation, okay? And it looks something like this. So to explain this, we'll say something like this. X is an element of R2. And so as such, you can, for example, I'll use an ordered pair like 2 and 3. Well, I can write this guy, this is a new thing, but I can write this guy as the linear combination of 2 elementary vectors. Okay, so I could write it as, in fact, I'll write it the way we do, 2, 3, can be seen as 2 times one vector plus 3 times another vector. And those magical standard or basic vectors are the vectors 1, 0, and 0, 1. So that means I can look at this as 2 times one of them plus 3 times the other. And again, I'll say 1, 0 and 0, 1. Look, writing it horizontally or writing it vertically, it's the same thing. And what that means is this particular guy, x, which is equal to 2, 3, let's say, is twice E1, we call him, the standard, plus thrice E2, okay? So that's the thinking here, okay? So whenever we multiply x by a matrix, we see something happening. You ready? So here's a neat thing that helps. It's a theorem. If I go A, which is say 2 by 2, let's just keep it 2 by 2, and I multiply by x, which is from this world of 2 by 1, so we're going to get another 2 by 1. What happens is you can use your knowledge and go, well, you know what? A is fine, but x can be written as, let's call it x1 times e1. Okay, so x1 is the coordinate, the first coordinate of x, times e1, just like up here. X1 is 2, the first coordinate, and then plus x2 times e2, like that. So what? Well, it's the story about multiplying with a matrix we have properties that say I can do something like, well, this is x1 times AE1, and then plus x2 times AE2 because of the properties of multiplying with matrices and vectors. Okay? All right, so what? So this is the same thing as multiplying this matrix, which is AE1, AE2 times x, x1 and x2. So in other words, whatever happens, whatever matrix you pick, okay, to do what you want it to do, its columns are made up of whatever it does to E1 and E2. That's the trick here, is go, well, let's watch what happens to little guy 1, 0. Where does he go under this transformation? Where does E2 go under this transformation? And if we can figure that out, they become the columns of the matrix you seek. See that? They're the columns of the matrix you seek right there on the screen. It's like, oh, really? It's a good way to go. So if we go after this problem, we can do it that way. So if we want to find the matrix A that does the trick, well, it's asking us to do two things. It says reflect across the x-axis and then stretch it by a factor of 3. So we'll do that, but we're going to ignore x right now and instead focus on what happens to this guy, which is E1. Okay, as you do this, you can be building A. A is going to be some sort of matrix. Okay, so let's find out what happens to E1. First, we're going to reflect it across the x-axis. So there it is. Okay, you know that guy is what? It's no longer 1, 0, it's negative 1, 0. That's what happened to it. And then it gets multiplied. This vector here gets scaled by a factor of 3. So where are we now? What is AE1 equal to? It looks like the x value is negative 3 and the y value remains 0. That's what we do. Negative 3, 0. Okay. And now another color. What happens to this guy? Okay, I shouldn't have done that color. Oh, well, I'm going to stick with it. This is E2, which is 1, 0. Well, he gets reflected across the vertical axis. Guess what? He doesn't move. He doesn't move at all. He's on the vertical axis, but then he gets hit by a scale of 3. So what is AE2 equal? AE2 is equal to, looks like it is 0, 3. And folks, that's your second column, 0, 3, and the problem's done. So it's a matter of just looking to see. You can convince yourself by multiplying various vectors to see that they get reflected and stretched. This is not a hard problem. The rotation thing through an angle has got its own little formula you can read about. We'll do it in class. But that's a start to this all. That's how you do it. This is why it works. Okay, next video takes us to the next chapter, I believe. So keep studying.